Hi and welcome to my Python YouTube channel. It's awesome to have you here. If you like this video, a thumbs up would be great. And make sure to subscribe for future videos. I also have a blog at prosperocoder.com with lots of cool stuff, so feel free to check it out. Today we'll see how to make a simple animation using Python. I'll be using the 2.81 version of Blender. In our animation, we're going to create a couple of objects that will move along sine waves. So first of all, let's save the project. So Control S, select your location, and the title could be something like sine wave. Okay. Now keep the default cube. Yeah, you heard me right. Don't delete it. Instead, change the color of its material to red. So materials, base color, red. And go to material preview to see what it looks like. Rename the cube red in the outliner. So double click it and type red. Okay. Now go to top view, 7 on your numpad. Duplicate the cube twice, each time moving at 10 units up. So Shift D to duplicate. And now Y 10 to move it 10 units up. Okay. And one more time, Shift D, Y 10. Fine. Now in the Materials tab, you can see the number 3 to the right of the name of the material. This means that 3 objects share this material. If you now change the color of the material of any of the cubes, all 3 will be changed because they share the same material. Have a look. Let's change it to green. All 3 change. Let's change back to red. So this is not something we want. We want 3 different colors. So in order to do that, let's start with the upper cube. It's already selected. And now click on the button with the number 3 over here. So this will make a copy of the material for private use of the first cube. The number 3 button will disappear. And now let's change the color of the cube to blue. And repeat the same step for the middle cube. Select the middle cube, click on the button with number 2, and change the color to yellow. Fine. Also, rename the 2 cubes blue and yellow respectively in the outliner. So this is blue, and this is yellow. Now, these names are pretty important because we're going to use them in code later. Now we're going to script the 3 animations for each cube separately. First of all, let's go to Scripting Workspace over here. In this workspace, you can see the 3D view editor in the upper left corner over here. You can make it a bit larger. And now go to top view, material preview. In this editor, we will also need a timeline for our animations. So hover your mouse cursor near the upper right corner of the Python console. This is the Python console. And drag, when the plus sign appears, you can drag this down to open a new editor and set the type of this editor over here to timeline. Good. Now the big editor on the right is the text editor. It's the one we're going to enter our Python code. First, click on New to open a new script and then open the sidebar by checking the sidebar box in the View menu. View, sidebar. Yeah, and now for better readability, you can change the font size to, for example, 16. Okay. When done with the font size settings, you can close the sidebar in the View menu like this. Just uncheck this box. And now let's import the Python modules and functions that we're going to use. First, the Blender module, bpy. Second, the Sine function and the pi constant from the Math module. So, import bpy. This is the Blender module. And now for Math, we're going to need the Sine function and the pi constant. Okay, now we're going to continue with our code. We need references to our 3 cubes. All our objects are in the bpy.data.object dictionary, and we can access them by key. The keys match the names that were given to the objects in the outliner. That's why I said it's quite important here. So let's save the 3 objects in the 3 variables, red, blue, and yellow. Red equals bpy data objects with the key red. As you can see, this matches the name in the outliner. So we can copy this line for the other 2 cubes, and now change this to blue. Again, this corresponds to this, and yellow. Fine. So now we have the references to our 3 cubes. Now this is going to be an animation, so we'll be working with frames and keyframes in the timeline. The animation should start at frame 0. So add the following line to the script. Frame number equals 0. And now we're going to work in a loop. The loop will iterate over the frames in the timeline and will insert keyframes at some of the frames. In each iteration of the loop, the location of the appropriate cube will be calculated, x, y, and z position. This is best visible in the code itself, so let's first animate the red cube in the loop. This cube will move along the x-axis in a sine wave. Now have a look at the code. Here we have the loop for I in range 0, 1, 1. Now this means iterate between 0 and 100. 101 is not included. This is how the range function works. And now what should we do in the loop? First, let's set the current frame. So bpy context scene frame set frame number. So in this line of code, we set the current frame to frame 0. Fine. Now we're going to calculate the x, y, and z location of the cube. When graphing the sine wave, by default we use radians instead of degrees. The points on the x-axis where the sine wave changes direction are multiples of pi over 2. So 0, pi over 2, pi, 3 over 2 pi, 2 pi, 5 over 2 pi, etc. This is exactly what our x locations are going to be. The loop variable I changes between 0 and 100 in each iteration. So let's start with x. X equals I over 2 times pi. Now, the y-coordinate is calculated as the function of x. To make the movement more visible, we'll multiply the result by 10, because the values range from -1 to 1, which is not much. So, y equals sine of x times 10. Now, the z location. We want the movement only on the xy plane, so we can set z to 0. Fine. Now we set the location of the cube using the coordinates just calculated. So red location equals, here we have a tuple with x, y, and z. And now we want to insert a keyframe. Red keyframe insert data path equals location index equals -1. Well, we use the datapath keyword argument to set the type of the keyframe. In our case, it's a location keyframe. We also set the index to -1, which means we're going to use x, y, and z location, so all 3 dimensions. Finally, we increase the current frame number by 5 frames. So, frame number plus equals 5. Good. This is our loop. Now you're ready to run the script. To this end, press the Run Script button over here. Okay, let's zoom out a bit to see the red cube. Okay. Now let's select the red cube in the 3D view and go to frame 0. Let's set the end frame to 500. Because this is how many frames we're going to need. Let's scroll down the mouse wheel to see all this range from the beginning to 500. And now you can see all the keyframes in the timeline. Location X, Y, and Z. Now if you play the animation, the red cube should be moving along a sine wave. So let's hit play. And so it does. It's moving along a sine wave. Okay, let's pause the animation. It's a good time to save. Good. Next, let's animate the blue cube. Now we need some changes. So this code is for the red cube. So let's just add a comment here. Red cube. And now we want to change the names of the variables to XR, YR, ZR for red. And we also have to change it here, XR, and here. Fine. And now, well, this will be for all the cubes the same. So let's add the blue cube over here. Blue cube. Now, the movement along the x-axis should be slower than the red cubes. To do that, you can divide I by a number larger than 2. So xb equals I over 3 times pi. The blue cube should move in the xy plane, but also in the xz plane. The base level of the cube should be 10 units above the x-axis, so we must add 10. Also, this time let's multiply the value of the sine function by 5 to flatten the movement. So, yb equals 10, which is the base above the level of the red cube, plus sine of xb times 5. And now we also want the blue cube to move along a sine wave in the xz plane. So let's define zb as sine of xb times 10. And now let's set the location of blue. So blue location equals xb, yb, zb. Fine. And let's insert a keyframe, the same as here. So let's just copy it and paste it over here. We have to change this to blue. Good. Location index -1, the same. Very good. Fine. And now we can play this script. We can run this script over here. Good. Now let's change the view to an angle from which it'll be more visible, easier to see how the two cubes move. Let's zoom in. Let's go to frame 1 and let's play the animation. So as you can see, the blue cube moves in 2 planes, whereas the red cube only moves in 1 plane. Fine. Finally, let's animate the yellow cube. So, let's add the yellow cube over here. Now this cube should follow a sine wave up the y-axis. So we have to swap the coordinates and make some tiny changes. First, we define the y-y coordinate. The xy coordinate will be dependent on y-y. This time we're going to keep to the xy plane, just like with the red cube. So, y-y equals I over 4 times pi plus 20 units above the base of the red cube. Now xy equals sine of yy times 5. zy equals 0. Now yellow location equals xy, yy, zy. And let's the keyframe. You can copy that again. Yellow. Good. And that's it. Now we can run the script. Fine. Now if we select the yellow cube, we'll see all the keyframes. And now let's go to frame 1 and let's play the animation. As you can see, the yellow cube is climbing up the green y-axis, moving along a sine wave, and the other cubes are moving along their own sine wave tracks. Fine. We are now done with scripting, so we can go back to Layout, Workspace, and here the animation will be just more visible. So play the animation and watch the cubes from different angles. So the red is moving only in one plane. The blue one is moving in 2 planes. The other one is moving in one plane but along the y-axis. Fine. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.